Hello, ladies and gents. Hope you're doing good today. So, our plan for today's lesson is to do a little warm-up on long division, which you should have learned recently. And then we're going to dive into synthetic division, which is awesome. All right, so here's what I want you to do. I have an example problem for you here. I'm going to ask you to try this, okay? If you try it and you don't feel confident, you can unpause this video, but I'd like you to give it a shot, okay? Really give it a try and see what you can do, okay? So I'm going to pause this, I'm going to do some work, and then come back and see what it looks like, all right? Okay, pause. All right, suppose you're a little stuck and you need some help getting started. Well, since we are dividing by x plus 3, that goes on the outside, and then 6x to the fourth goes inside, followed by 15x cubed, followed by, if you'll notice, I have not one, but two placeholders because I have a fourth degree term, a third degree term, but I have no second, no first. So I made those placeholders. So if that was what you needed to get started, then pause me again and come back. All right, if you needed some help with the second step, I picked 6x cubed because when I multiply that through to x, I get 6x to the fourth, which is the same as my original term. And then I also multiplied it to 3 since I have to distribute to everything, and that gave me 18x cubed. Now notice I have these blue negative signs. It's because every time when you are dividing, you're supposed to multiply through by the term you picked and then subtract, which will cancel out those two terms, and then positive 15 minus 18 should leave me with negative 3x cubed. All right, see if you can figure it out from there. All right, off you go. All right, as you can see, some work has happened. Now I have picked negative 3x squared to get rid of my negative 3x cubed term, because I multiplied that through twice. I also got a negative 9, but had to change it to positive when I subtracted, because remember that a negative minus a negative is actually a positive. All right, so that left me with 9x squared plus 0x because I carried that down. So now I need to pick something to multiply by, so I'm going to pick 9x. So that's going to get me 9x squared plus 27x. I need to subtract, which will switch my signs. So those will cancel, and I'll be left with negative 27x. Another term to carry down is positive 6. I'm going to need to multiply by negative 27x minus, 27 times 3. Let's see. 2 times 3 is 6, so that's negative 60. Negative 60. And then 7 times 3 is 21, so that's negative 21. So that looks like negative 81. I get it, you could use a calculator, but come on, who needs those? Okay, add, because I'm switching my signs. All right, so that's a grand total of 87 as my remainder, if my math checks out, which I like to hope that it does. All right, so everything up above that, that's your answer. All right? Okay, so next thing that we need to work on is our topic for today. So far I have taught you some division of the long variety. That's this right here. Remember, that's where you take any polynomial and divide it by another of any degree that's less, okay? Something that you've done, you probably just didn't realize you did it, is dividing by a monomial. It's kind of like a fancy way of saying you're going to take out a, let's not use the highlighter to do this type of writing. All right. This is a fancy way of saying that you're taking out a GCF. Okay, let's be realistic about that. 6x to the fourth and 4x cubed are in fact both divisible by 2, and x squared, that would leave me with, let's see, 3x squared minus 2x. The only difference is what I took out wasn't the greatest common factor. It was like taking out a greatest common factor, not exact. So it's not always the exact greatest common factor. All right, synthetic division. That's what we're going to learn about today. Aren't you so excited? Okay, key thing about synthetic division is that you're going to have a term that has a 1 in front of the x. So for example, things that are okay, things that look like x minus 6. Something that's not okay would be something like 2x minus 5. Do you know why? the 2. No good. No dice. All right? There's a 1 there. That's okay. That's nice. We like that. But anything that's like this, it's really annoying. So you don't want to use synthetic division when the a value, the number in front, is not 1. All right. Hopefully I have stressed that enough. Time for some coolness. By the way, part of the reason why this is called synthetic division, synthetic's kind of like fake, is because we're not really going to divide. You'll see what I mean in a second. Okay, so in order to divide using synthetic division, the first thing you have to do is take your factor and set it equal to 0 and figure out what root, what solution you're testing. Think back to x-intercepts. Basically, what's the x-intercept you're trying to figure out, like whether or not it works? So the x-intercept we're testing here is x equals 2. Because if x minus 2 equals 0, then x would have to be 2. All right? So we are going to take that 2 and we are going to write it in front. And then we're going to make a different kind of bar, okay? Kind of like a really long L. Then we are going to take all of the coefficients in front of our terms, and we are going to write them inside this fancy little L. Notice all of our terms go down in degree, so we're not missing any. We don't need any placeholders. And the first one's 1. So 1, 2, -6, and -9. Notice I took the sign with me, all right? Okay, time for the cool part. Here's the process. We are going to take the first term, just drop it, all right? So instead of dropping at the end, we're dropping at the beginning. This is synthetic, so it's kind of fake. Then we are going to multiply. That should feel very similar to long division. So 2 times 1, and we're going to write that up there. So that's 2. And then, what did we do before? We subtracted. We're not going to subtract here. Here, we are going to add. I know, seems a little crazy, right? So we're going to get 4. And then we're going to repeat that process. 2 times 4 is 8. -6 and 8 is 2. 2 times 2 is 4. -9 and 4 is -5. All right? What on earth does that mean? 1425? Do I add it all together? No, that is not what that means. Okay, think about this for a second. I took something that was x to the 3rd, and I divided it by something that was x. So if you just think about the exponents, I'm going to end up with something that's x squared, right? Because I have to get rid of one exponent degree. That's what happened here. This 1 means you have 1x squared. This 4 means you have 4x. This 2 means you have a positive 2. And this remainder, you can write one of two ways. You can have -5 over x minus 2, or you could tell me that your remainder is -5. Either one of those is acceptable. All right? One last thing. I normally put a little box around this to signify that that is the remainder. All right? We're going to try example number 2 now. Okay, so x plus 4 is my factor. So that's the first thing I do is I take x plus 4, set it equal to 0, so x is -4. All right? So that means -4 goes out in front of my fancy little box here. And then I want to take a look at my coefficients. So x cubed, so 1, -14 for x squared. Now notice I need a placeholder because I go from 2 to none, so I need a 0 and then an 8. All right? Then it's time to have some fun. So I drop the first one automatically, then I multiply, then I add, and then I repeat. Ooh, -4 times -18 is positive 40 and 32. So what is that? 72? Yeah, sounds right. Hope it does. All right, 72. Ugh, that's going to be really large. Ooh, -4 times 72. Oh, I guess I'm going to get out my calculator. It's a little, I mean, it's, 288, I think, but I don't want to, mess you up. So, all right, 288, but the negative variety. Holy cow, -280 is your remainder. That is so not a factor. Okay, so my solution is going to be x squared, because that's 1 less than my degree, minus 18x plus 72 with a remainder of negative 280. All right, I want you to try example number 3. So pause this video, but pay attention, it's not in order. So rewrite it, x cubed plus 3x squared plus, I don't have an x, minus 4. All right? Okay, you give it a try. Pause. Ta-da! All right, did you get 0? I hope you got 0. I love it when we get 0. All right, so what does this mean? 1, 4, 4, 9? Nah. Okay, it means if my degree is 3, this becomes x squared plus 4x, because that's 1 less degree, plus 4 with no remainder. And remember, you can always check your work to make sure that that is correct by taking this polynomial, multiplying it by x minus 1, and you better get the original. Okay, all right, a couple more examples. These 2 examples, I want you to try, you guessed it, on your own. See if you match the work I show you in the video. All right, see you back here in a minute. You go. No, but seriously, off you go. Ugh, she's so mean. That's probably what you're thinking about problem number 4. Sorry, there were a lot of zeros. If you wanted to see why there are 3 zeros, we started with x to the 4th, and we didn't have anything else with an exponent. So 3 zeros, you carry everything down. All this mumbo jumbo with the 1s and the negative 1s means you have x to the 3rd minus x squared plus x minus 1 with a remainder of 2 as your answer. All right, come on, pause me so you can try number 5. I promise it's not as many zeros. Okay, have fun. See, told you, less zeros. You know, only 2 this time. Okay, so you should have gotten 6x to the 3rd minus 3x squared plus 9x minus 27, remainder of 87. Now, for those of you paying attention at home, check this out. Example number 5 is actually your warm-up. Bah ha ha ha. And notice we got the same answer. Should that happen? Yes, it should. Come on. No matter what way you divide, you should get the same answer. All right. So where are we at? We're at number 5. Check that out. All that fancy math. Okay. All right. So now it's kind of up to you on what you want to do with the rest of your time here. Here are some example problems, just reviewing your basic skills of using polynomials, all right? Combining like terms, multiplying, subtracting, okay? And then sort of a big connection is understanding the idea of dividing and multiplying. So follow along with these directions if you would like. Otherwise, you may start on your homework, okay? Any questions? Go back and watch this video again. Send me an email. All those great things. Hope you've enjoyed synthetic division. Have a good one, and until next time, enjoy.